Ladies and gentlemen, welcome back to Math 30-1, Chapter 3, Section 2, Reflecting Graphs of Functions Notes, Part 2. Now, example question 5. This function is given by y equals f of x. Determine the expression for y equals f of x. Come up with the equation. We did that in Chapter 1. Just a little review for you. So that's going to be what? Come on. Now it's a cubic, so it's x plus a times x plus b times x plus c, something like that. Now looking at this, x equals minus 1. Add 1 to both sides, so this is x plus 1. That's x plus 1. Another coordinate is here. X equals 1. Subtract 1 from both sides. X equals minus 1. Sorry. X minus 1. Barakazad. So maybe I should say x minus b and x minus c. Be a little more accurate. And then I'll just put the generic plus because I can. And I think we can all see this is x minus 2. I'm not going to prove that. But what I am going to go is, what the heck is a? Well, I've given you one other coordinate there. 0 minus 4. Now notice I usually give you the x-intercept here, not always. I'm sorry. Y equals. So every time I see y, I replace with minus 4. Every time I see x, I replace with 0. And we solve for a. So minus 4. This is 1 times minus 1 times minus 2. Minus 4 is equal to 2a. A is minus 2. Okay, so this equation is y is equal to minus 2 times x plus 1 times x minus 1 times x minus 2. All right, so that's the equation. That's a review from Chapter 1 you should be able to do. Determine the expression for the image after reflection across the x-axis. X-axis, y goes to minus y. So this becomes minus y equals minus 2 x plus 1 times x minus 1 times x minus 2, or y equals 2 times x plus 1, x minus 1, x minus 2. All right? Now, determine the expression after reflection across the x-axis. Sorry, across the y-axis, my bad. That's x goes to minus x. This one gets a little sneaky. Let me see. Now, this is badly worded, but I think we're referring to the original equation. Minus 2 times, this would be minus x plus 1, minus x minus 1, minus x minus 2. All right? So far, so good? Now, I saw this on the diploma once, and they were a little sneaky about it. Here, I want you to realize there's different ways to write this out. And what I'm trying to say is they simplified it. So, minus x minus 1, factor out of minus 1, x plus 1. And minus x minus 2, they factor out of minus 1. Now, minus x plus 1, I think they wrote that 1 minus x. They wrote it backwards just to screw with me. Now, the reason I'm talking about this is I want you to realize, oh, minus 1 times minus 1 cancels out. So this could be written okay. So there's more than one way to write this out. You've really got to be careful. And what I'm trying to say is graph the damn thing. All right? Because they could give you 4 possible answers for this, and it'd be a pain in the bum. It's probably excuse me, a lot easier to graph it. Now, so far so good? Now the last thing is mapping notation. Now in part B, x comma y went to x comma minus y. Y became minus y. In part C, our coordinate went to minus x comma y. Now written like this, it's called mapping notation, and it's something you will see you are expected to know. A generic point. What do we do to the generic point on the graph? And yes, I'm going to give you more examples. Of course I am. All right. So question 6, the function y equals g of x has a domain of -3 is less than or equal to x is less than or equal to 12, and a range of y is greater than or equal to -4. Determine the domain and range of y equals minus f of x. Notice there's no graph here, just numbers. So here, y goes to minus y. So my domain doesn't change. My range, on the other hand, I multiply that by -1. So I'd end up dividing both sides by -1, so y is less than or equal to 4. Okay? Domain and range of y equals f of minus x. That's x goes to minus x. So what happens? Yes, I get -3 is less than or equal to x. It's going to equal to 12. Well, technically, this becomes minus. So I divide everything by -1. When I do that, everything flips. So it's 3 is greater than or equal to x is greater than or equal to -12. Now I could write it like that, but that screws things up. I should go -12 is less than or equal to x is less than or equal to 3. Or -12 comma 3 if I want to get fancy with the brackets. Well, domain. And notice nothing happens to the range. My range, y is still greater than or equal to -4. Or to be fancy in the square brackets, -4 comma infinity. All right. Let me see. So the function y equals mx has x-intercepts at -4 and 3, a y-intercept at -6, and a vertical asymptote at x equals 1. So determine the x-intercepts and asymptote of the graph y equals m bracket x minus 7. Now, this is a review from last class. This means write 7 units. So x goes to x plus 7. So my intercepts, -4 plus 7 equals 3. 3 plus 7 equals 10. And, oh, my horizontal asymptote is 1. Hey. Vertical asymptote is now 8. Now, determine the x-intercepts and asymptote of the graph y equals m of x plus 2. This is left. 2, remember, it's x minus 2. Yes, I'm repeating that again, even though I talked about it yesterday. Anyway, so this goes, let me see. X goes to x minus 2. So my asymptotes, sorry, my x-intercepts were -4, -2 becomes -6. 3 minus 2 is equal to 1. And my asymptote was +1. -2 becomes -1, so that's vertical asymptote. X-intercepts. Now, determine the x-intercepts and asymptote of the graph y equals m minus x. What are we doing here? This is something we talked about today. X, come on, oh, don't do that, you poopy head. Let me get through this last example before you start pooping out. X goes to minus x. What happens here? So my intercepts, -4, times minus 1 is equal to plus 4. 3 times minus 1 is equal to minus 3. My vertical asymptote was at plus 1. As minus 1 becomes minus 1. All right. Now finally, determine the y-intercept of the graph of y plus 5 equals m of x. Review from last class. I really should write this as y equals m of x minus 5 or down 5. So my y-intercept, y minus 5, that's minus 6 minus 5 is minus 11. So my new y-intercept would be minus 11. All right. Now I'm going to pause the recording here. Watch the video again if you got any questions, or shoot me an email. Otherwise, let's go on.